EDXL Core Pure Matrices 2 Transformations and Invariants. Successive transformations in 2D. So previously we've looked at reflection matrices, and at this point you could pause the recording and try the left hand rule to see if you can identify the following matrices. So here, this matrices, the 1 0 has remained at 1 0, so the thumb hasn't moved, and the index finger has moved to 0 minus 1, and that would be a reflection in the x-axis. Using similar methods, you could identify the following matrices. Likewise with the rotation matrices, you could pause the recording and see if you can identify the following matrices using the left hand rule. So the first matrix represents a rotation of 90 degrees about the origin, anti-clockwise. The direction of the rotation is very important. And then we have a rotation of minus 90 degrees about the origin, a rotation of 180 degrees about the origin, and be careful with the last rotation matrix. It's a rotation of theta degrees about the origin, and a clockwise rotation is considered to be a negative rotation. So here we have some stretch and enlargement matrices. So the first one is a stretch by scale factor k parallel to the x-axis. The y-coordinate would stay the same. And likewise, there's a stretch parallel to the y-axis, a stretch horizontally by h, and a vertical stretch by k. And the last one is an enlargement scale factor 2. So what we're going to look at now is we're going to look at successive transformations. So to start off with, I'm just going to do a visual transformation. So the first thing we're going to do is to take this red object, and I'm going to apply the matrix 1 0 0 minus 1. So that is an x-axis reflection. So my image will end up at these points, and my image would look something like that. So that's the application of matrix A, followed by matrix B. So this is 0 1 minus 1 0, which is a 90 degree anti-clockwise rotation. So my image this time would end up, after a 90 degree clockwise rotation, would end up there, there, and there. So the final image would look something like that. Okay, so just a quick recap. So that's applying matrix A, so that's an x-axis reflection, followed by a matrix B, which is a 90 degree anti-clockwise rotation. So we think the image should look like that, and we're going to check that now by looking at A followed by B, but using the matrix multiplication. So the first one we're going to do is BA, so that is applying A followed by B. So making sure we get things the right way around. So BA is 0 minus 1 1 0. After we've applied A, which is 1 0 0 minus 1, and if we multiply those together, we get the matrix 0 1 1 0, and that combined effect of A followed by B represents now a reflection in the line y equals x. And we can see that the image, the pink image that we got, is indeed a reflection of the red object in the line y equals x. However, if we consider AB, so that's A, 1, 0, 0, minus 1, and we're applying that matrix after we've applied B, which is 0, minus 1, 1, 0, we get a combined effect of 0, minus 1, minus 1, 0. And that matrix, as you may remember, represents reflection in the line y equals minus x. So it's very important that we get the successive transformations in their appropriate order. So the order we wanted, A followed by B, is indeed this first case here. B times by A would represent applying matrix A followed by matrix B. So just to summarise, we've got two matrices called M and N. The matrix NM gives a single matrix which represents applying M followed by matrix N. The matrix MN gives a single transformation which represents applying matrix N followed by matrix M. So as a little example, can we find the matrix S that represents a stretch of scale factor 3 in the y direction followed by an anti-clockwise rotation about the origin of 90 degrees? So let's look at the first matrix that we're going to apply would be the stretch scale factor 3 in the y direction. So stretch scale factor 3 in the y direction I'm going to call M, and that matrix would be 1, 0, 0, 3. So I'm stretching the y coordinate by a factor of 3. I need to follow that now with an anti-clockwise rotation about the origin of 90 degrees, which I'm going to call matrix N. So an anti-clockwise rotation about the origin of 90 degrees, so that's 0, minus 1, 1, 0. And to find S, so I need the scale factor matrix followed by the rotation matrix, so that would be applying M and then afterwards applying N, so that would be N times M, so that's 0, minus 1, 1, 0, multiplied by 1, 0, 0, 3, which would give me the matrix 0, minus 3, 1, 0. So that is the combined matrix S. And there's the diagram showing the effect of S on an object. So we've got the original pink object, and if we stretch that by a scale factor 3 in the y direction and then followed that with a 90-degree anti-clockwise rotation, they would create the blue object, and that single transformation to achieve that would be the matrix S. In the next session, we're going to be looking at transformations in 3 dimensions.